Okay, so here we go. We're going to review this, some of the problems on this worksheet that we looked at in class today. Okay, we're looking at our study on parametric equations. These are written as x as a function of a variable and y as a function of a third variable as well. In most cases, that third variable is thought to be time. Okay, and actually these are motion equations. So we're going to go to Desmos to illustrate, we get the x and y coordinates, we plot them, we get a graph. That's a static graph. It's not a graph of motion. The graph of motion is best illustrated with our look at Desmos. So let's go to that, okay? So here was, the graph that you should have come up with as illustrated here with the dotted line, okay? That's, again, that's the static graph. Now, if we need to, I'll remind you, I'll rebuild that for you if you need the memory of that. But here is the motion graph, okay? And so this is the path, okay? This is the motion. This is the dynamics. This is the motion, which means you don't need to look at that. This is the motion taken by the particle being driven by these parametric equations, okay? So let's just remind you of how that was put in place, okay? So I'm just going to go up and start over another Desmos here. Actually, let me go back here and just kill this and restart it again, okay? So that we can, we can just, we're going to delete it, and we're going to start from scratch, okay? So if I wanted to put in these sets of parametric equations, okay, I put them in as coordinates just to refresh your memory, just so that we're on top of this, okay? So I put those in as coordinates, which means with the parentheses, and in terms of the variable t, so this was the square root of t squared plus 1, comma, the 2 minus t, okay? And this is, of course, this is, for some reason, not working, okay? Oh, that's because that's a minus. So t squared minus 1, and there's a parameter listed there for t. My parameter went from -2 to, okay, sorry about that. Kill that. That's, we're going to start from scratch again. For some reason, we're having a little difficulty here, okay? Get my parentheses in, okay? The parameter is square root of t squared minus 1, and outside parenthesis, comma, 2 minus t for the y value. Okay, my t value is going from -2 to +6. Okay, from -2 to +6, and t squared plus 1 was the actual. Okay, so there's the path. Okay, that's the path of the particle, but that's not the motion of the particle. So what I needed to do was then I need to duplicate this. So to duplicate that, I went, edit, okay, go down here, duplicate, come down here, and then here's where I duplicated, okay? However, I needed to change up my variable, so I changed that to variable A. I'm going to change this to variable A, okay? And I'm going to implement my slider on A, going from -2 to +6. Step is continuous, so I'm leaving that blank, okay? Here's the motion of the particle. Not true, because it doesn't travel backwards in time. So I'm hitting my one directional arrow, indicating that that's how it's going to go. I'll dress this up a little bit by altering the color code maybe, okay, and the dotted path, if you will. Makes not much of a difference, okay? So that's done. And so now actually, so this is not part of the parametric equation. The parametric equation is strictly the motion indicated by this particle driven by these sets of parametric equations, okay? And that's pretty much the gist of what we discussed, okay? So just to give you a recap, and that's that. Okay.